Hi there, welcome back to my channel. So in this video, I'll be taking you through decimal to binary conversion, specifically using the repeated division method. In our previous lessons, we used the decomposition method to convert decimal to binary. So let's see how we can use the repeated division to do same here. So let's convert 25 base 10 to binary. So using this scenario, I'm going to illustrate how we can use the repeated division to solve this problem. So what do we mean by repeated division? We want to convert our number here to base 2, right? You know, base 2, we deal with what? 2 as a base, right? So we keep on dividing our number, which is in a decimal, with what? The number 2. So 25 divided by 2. Then you'll be writing the remainders what at the different side. Okay. So let's say you can draw a nice table like this. Okay, then maybe you put your 25 here, right? Then for the right side of the table, we simply have remainders. So let's make here r, which is the remainders. Okay, so now we have our 2 somewhere here. Okay, so you see that 2 goes into 25 how many times? 12 times, right? Then 2 times 12 is what? 24. So you subtract 24 from 25, then what are you getting? You're getting 1 as a remainder. Is that not it? Then you come again. So 2 go into 12 how many times? 6 times, right? 2 times 6 is what? 12, right? So 12 minus 12 becomes what? 0. Is that not it? So our remainder is 0. 2 go into 6 how many times? 3 times, right? 2 times 3 is what? 6. You write your 6 here. 6 minus 6 is what? 0. 2 go into 3 how many times? 1. 2 times 2 is what? 2. Then 3 minus 2 is what? 1. Remainder 1. Then finally, 2 go into 1 how many times? 0, right? 2 times 0 is what? 0. Remainder what? Remainder 1, right? So yes, so now this is the remainders we have. But in order for us to write our binary figure, we start from the least significant bit here. So for the remainder, our least significant figure is the very first remainder. Take note. The least significant figure is the very first remainder, okay? And the most significant bit is the very last remainder. This is because you realize that 2 will divide 25 by a huge number only when you are dealing with for the last number, which is the least significant bit. But a maximum significant bit when divided by 2 will give a very small remainder, or will give a very small number. That is 0, right? That is 0. Okay, that is 0. Take note. As I told you that our LSB is of smaller value, okay, then our MSB is of greater value. So whenever you divide your decimal value with LSB, you should get a very big number because it's small. And whenever you divide your decimal value with the MSB, you should get what? A very small number. So you can see that 2 go into what? 25. Using the MSB, it was 0, right? Then using the LSB, it was what? 12. That should tell you the difference. So always, to write your phone number, your MSB start from what? The last one. So here, 25 base 10 to what? Base binary number becomes 1 1. That is moving up, okay? 1 1 0 0 1 base 2, okay, base 2, 1 1 0 0 1 base 2. So take note of this, right? Now let's see another example here. Convert, let's say, let me put 25 itself so that we maintain this point, let's say 6 5, right? Base 10 to base 2 to binary. Okay, so how do we do this? So in the presence of a decimal number, how do we, the decimal parts, as I said, floating points, right? In the decimal of 0.65, we already know the 25. That is why I'm using this. So this is simply the 25 aspect. But how do we solve for the 0.65 parts? So here, this is what we do. There is a difference here. So for the difference, we are having something like this. So here we don't divide. Whenever you are doing for the right side here, we don't divide, but we rather do what? Multiply. Okay. So our number is 0.65. Is that not it? Then let's say, let me put what you get here. Then I'll put what? Let's say results. Okay. Then this is remainder. Okay. Something like a remainder. Okay. So with this table, I have 0.65, I have my 2 here. So 2 times 0.65, that's the first thing you do, okay? So simply multiply 2 times 0.65, okay? And that is giving me what? 1.3, right? So 2 times this is 1.3, okay? Then we only take what? The 1 as our remainder. We are interested in what? The 1, okay? So we put the 1 here. Then you know that we are left with what? 0.3, right? So now 2 times 0.3, what are you getting? 2 times 0.3. So 2 times 0.3 is what? 0.6, right? So here, for this 0.6, you are only interested in this number here. So you write 0. Then we are still left with 0.6. So this is what we do. So let's see. So we only take, as I said, we only take what you have here. I mean, what is at the left side of what? Our floating point, which is what you know, popularly known as decimal point. Okay. So at this point, you multiply 2 by 0.6. What are you getting? 1.2. Is that not it? So 1.2 here, I said we take the 1, then we leave the 0.2. We still go on with our 0.2 here, right? 0.6, 0.2, sorry. So if there's 0.2, I'll multiply 2 by 0.2. What am I getting? Which is 0.4, right? So 0.4, I'll take what? 0. Is that not it? So with 0.4 here, I'll still multiply. Here will be 0.4. I'll still multiply 2 by it. I'm getting what? 0.8, okay? Then 0.8, I'm getting what? 0 here. Then I'm getting my 0.8, the 0.8 here. So times 8, I'm getting what? 1.6. I'll have 1, right? So I'll have 1 here. Then finally, I'll have 2 times 1.6, which is what? 3.2, right? 0.2. Oh, sorry. Sorry. So I'll take the 0.6 instead. So we are coming back to the 0.6 parts once again. So 0.6, we're getting 1.2 in that order. So 0, right? So I think we need to stop right here. 1. I think we need to stop right here. So we'll have, so whenever you are doing for the right side, you take it this way. So whenever you are doing for the right side, our most significant bit starts exactly from the first one. Okay, so to be something like 1010001, right? 101001, right? And it's simply this after the decimal point. So our 4, we just introduce our, we simply introduce the 25 parts, okay, which is 11001, right? 11001. So 11001 dot all this base 2. So this is how we convert the numbers which are from decimal to what? To binary using the continuous division. But with the decimal points, that one we use continuous multiplication. Okay. So thank you for being in this video. Don't forget to like, subscribe, and share.